Okay, so I'm going to give you a little crash course on simplifying these square roots. So first thing to notice that if there's a negative in there, that just means there's going to be an I in the result. So whenever I see that, I can just like kind of get rid of it, cross it out. That just means there's going to be an I in front. But the tricky part is simplifying the number inside. So let me go back and add that negative back in. So there's two real ways you can go about doing this. You can either look for, like you said, the largest or any perfect square that goes into 192. Okay, so you could say, all right, I just stole my answer how I got that, but let's see. Say something like, does 4 go into 192? So I could do 192 divided by 4. 4 does. So you don't always have to find the largest perfect square. You just have to find a perfect square, and then you can repeat the process over again. So you could say, maybe does 16 go into 192? It does also. So let's say I just decide to go with 16. Okay. So then I can write this as the negative is going to come out. This is going to be I times the square root of, I just said that 192 is 16 times 12. So this is a perfect square. The square root of 16 is 4. So I can write this as 4I root 12. Well, then I say, can I do that again? 12. Is there any perfect squares that go into 12? So I list out my perfect squares. 4, 9, 16, 25, 36, 49. Do any of these numbers go into 12? Well, 4 does. So I can write 12. This is going to be 4I root 4 times 3. And then I say, okay, well, 4 is a perfect square again, so I can take that out. The square root of 4 is 2. So if I multiply the 2 by the 4 out front, this whole thing becomes 8I root 3. Okay, that's the first method. Basically just doing what you kind of mentioned, finding the a perfect square or the largest perfect square that goes into this number, and then just keep taking it out. If you don't want to try and find the largest, you can just keep doing 4 as many times as you can get it, or you can try to find one larger than that. The second way is to just list or rewrite this as a product of prime factors. So the way you can do this is say, all right, I always look at this number and say, does 2 go into it? Yeah. So I'd say, all right, 192 can be written as 2 times, what is that, 96. 2 times 96 is 192. Then I say, all right, well, 2's done. 2's prime. I'm done with that. So can I not write 96 as a product of primes? Well, 96 can be written as 2 times 48. So 2's done there. 48 I can write as 2 times 24. 24 I can write as 2 times 12. 12 I can write as 2 times 6. And 6 I can write as 2 times 3. So then when I want to rewrite the square root of negative 192, the I is going to come out. And I'm just going to count off pairs of matching numbers at the bottom of these branches. So here I have a pair of 2's. That's one pair of 2's. Here I have a second pair of 2's. Here I have a third pair of 2's. So then I have 3 pairs of 2's. So outside my square root, it's going to be 2 times 2 times 2, which is 8. Inside the square root is going to be the remaining number that doesn't have a pair with it, in which case I still get 8I root 3. Just to show you a different example, let's say I'm just going to make one up, so I don't know if it's going to work out nice. Let's say I had the square root of, I don't know, 112. Let's just see what that does. All right. So I say 112 I can write as 2 times, what is that, 56. 56 I can write as 2 times 28. These don't always have to be 2's. If this isn't even, you could try and see if a 3 comes out or something bigger than that, a 5 comes out. any prime number, 2, 3, 5, 7, 9, whatever. 28 I can write as 2 times 14, and 14 I can write as 2 times 7. So again, I circle the pairs of matching prime factors. I have a pair of 2s, a pair of 2s, and a 7 left over. So this now becomes 2 times 2, which is 4 root 7. Let me think of one more that's a little different. So let's say I did the square root of negative, let's see here. I'll say 189. No, that's a perfect square, 189, I think. No, let's do that. 189. Let's try that. Okay, so the negative is going to come out, so my result's just going to have a negative in front of the square root. So you can kind of disregard that now. So 189 I can write as 2 doesn't go into it, but I can write that as 3 times 63. 63 I can write as 2 doesn't go into this, but I can write this as 3 times 21. And 21 I can write as 3 times 7. There's my prime numbers. I'm going to circle matching pairs. So there should be one set of 3, so that gives me a 3 out front. And then I have a 3 that's not matched and a 7 that's not matched. So this is going to be 3 times 7 inside the square root. 3i root 21.